So what we have now is we have all of our printed information. Okay, as we move forward now, this is where it's going to be the exact same cues I'm going to say every time. Okay, pulling this information out, it's going to be this it's going to look the same every time. So if we take a look at our graph, once again, this will be an acquired thing. I take a look that I have a vertical phase shift of 2. I have an amplitude of 3. Okay, so if I have a vertical phase shift of 2, that means I'm going to slide my graph up 2. I have an amplitude of 3, so that means if I slide up 2 and I have an amplitude of 3, I have to at least max out at a value of 5. So I need to make sure I need to get up high enough. And if I take a look at my vertical phase shift of 2, my amplitude of 3, my bottom value is going to be -1. So I can be a little bit more top heavy in regards to my graph. I don't have to be right here in the middle. And this is something that as you go through this, you'll get more and more used to what our graphs will look like. I have my theta and I have my y. I'm going to count up. Six. I'm going to go down to okay, and knowing the features of what the graph does with regards to a vertical phase shift, your amplitude will help you and assist you in regards to your problems. My spacing here, I have a horizontal phase shift of -60 and I have a period of 180. So I'm going to space out my 90s here. I'm going to make my 90s pretty big. So I'm going to have -90 here, 90, 180, and 270. And I can divvy these into thirds. Like I said, just relax. You will continue to get better at spacing this out. First one's typically a rough one. All right, the first thing we go to is the vertical phase shift. It's going to be the first thing that you're going to want to put in every time, the vertical phase shift. Because the vertical phase shift, what that's going to give us is going to give us this prime axis or that neutral axis that you're going to oscillate about. Okay, so you're going to draw in your prime axis first. That gives us something that we can go up from and go down from. Go up, down, from, and down from. So we're going to oscillate about this. So at the value of 2, we're going to draw in our prime axis. Okay, always the first thing you're going to draw in. The second thing, we look at two things for the second thing. we look at our horizontal phase shift, which gives us a theta start value, and our trig function. Our trig function will tell us, do we start on our prime axis or at our peaks and valleys? So we look at two different things here because we need to know where to start this graph at. Okay, we looked at where do we start the graph at? Well, we started at, okay, our theta start value is the first thing we take a look at -60. But the trig function, sine or cosine, tells us, do we start at our peaks and valleys or on the prime axis? Well, since we have a sine function, we start on the prime axis. So on our prime axis, at -60, on our prime axis, we start our graph. So the first thing we look at is our prime axis. Second thing we take a look at is our horizontal phase shift, our theta start value, and our trig function. Yeah. Okay. So we start on the prime axis at our -60. The third thing is the period. The period is the number of degrees in the cycle. The cycle is a portion of the graph to a portion of the graph where it starts to repeat itself. We start at -60. We have to travel 180 degrees. At 180 degrees away from -60, we'll be at the exact same spot. So if we start at -60 and travel 180 degrees to the right, how many degrees or what degree measure will we be at? If we start at -60, we go out 180 degrees, what degree measure will we be? 120. So at 120, 3690, 120. At 120, we have to be at the exact same spot. Why? Because that's what the definition of the period is. It's the number of degrees in the cycle. Cycle is a portion of the graph to a portion of the graph where it starts to repeat itself again. So at 120, we start to repeat itself again. These cues will be the same each and every time as we go through. We find all this information here. Okay, first thing we draw in, vertical phase shift, prime axis. Second thing, we take a look at the theta start value, horizontal phase shift, and our trig function. It tells us to start on the prime axis at -60. Period tells us at what degree measure will we be at the exact same spot again. -60, 120 degrees, that's 180 degrees away. The other way of doing that, take your horizontal phase shift, and just add the period to it. -60 plus 180, that will give us the value. Now we play games of halves. Okay, our games of halves. Now remember what a sine curve looks like. Sine curve, click, 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 climbs the hill. Scream, ah! All the way down the hill, then back up again. Okay, same thing here. We're going to climb the hill, click, 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 climb the hill from the sine. We're going to scream all the way down, ah! Underneath, and then back up again. Okay, so we start playing our games of halves. What's the halfway point between -60 and 120? Okay, games of halves. Add the two together, divide by 2. Add them together, divide by 2. Chloe, what do we come up with? 30 degrees. So we have -60 plus 120. That gives me 60 divided by 2. I have 30 degrees. Okay, question is, where's my y value at? Well, I'm going to climb, climb, climb. I'm going to scream. I'm going to go underneath and then back up again. So where do you think we're at with our y value, Chloe? I'm sorry, what? Not -2. I'm going to scream and I'm going to come down through, then back up again. Nah, not 0. I'm going to climb. Then I'm going to scream down through on the prime axis again. Okay, the other thing, things you'll start remembering. Between 2 points that hit the prime axis will be another prime axis. Okay, that could be a prime axis, a sine curve. I guess that's a bad one there because I have 2 here. Okay, so I'm going to climb, then I'm going to scream down through, then back up again. Halfway point between negative 60 and 30. Add them together and divide by 2. Grant, what do you have? 15. Now the question is, where are we at with our y value? Now we're going to climb the hill up at 5. Very good. So we're going to be at the peak at 15. We're going to climb the hill to the peak. We're going to scream down through. Then we're going to go underneath. Halfway between 30 and 120. Sydney? Halfway between 30, add them together, divide by 2. $30 plus 120. Divide by 2. 75. Okay, so it's 75. Question is where we're at here. We're going to climb the hill. We're going to scream. We're going to come down through. How far low do we go? Negative 2. So we're at 2. I have an amplitude of 3, so it's going to take me down to negative 2. I'm at 2. I'm going to go down 3. Negative 1. So at 75, we're at negative 1. My last thing to throw in is my y-intercept at 4.6. If I look at, here's 5, here's 4, 4.6. If I take a look at my graph now, I should have a nice flow through my y-intercept and back up again. As you go through mathematics, as you get to upper level mathematics, as you continue to move through the mathematical careers, you have to have patience within the problem. Okay, you have to have patience when solving these problems. It is just not a quick clickety-clack through the calculator and come up with an answer. Okay, there's multiple steps that go through. You have to go through to get through these problems. Okay, and you just have to have patience. Is it difficult work? No, it's not difficult. It's just multi-step work, and you just have to be patient as you go through that. Okay, so what I want you now to do next problem. Find the amplitude, period, vertical, horizontal phase shift, and your y-intercept. Check your answer with somebody around you. Yep. Well, you can do that way. 360 divided by half. You just have to make sure that you quantify the half when you do the division.
You guys are right.
Okay, let's take a look. Amplitude period. What do we have for amplitude and period here? Let's say what we have. Johanna, okay, that's fine. Amplitude period. 2 is the amplitude period. How'd you get it? That'd be divided by 2. Okay, so it's 720. It may help you if you go 360 divided by a half, which is times 2. So you have 360 times 2, which is 720. Vertical, horizontal phase shift. What do we have for those? Brandon?
Vertical one's -1. The horizontal is -90.
That is correct. Once again, this is theta minus the -90. So it's theta plus 90. Y-intercept. What do you get from my y-intercept, Matea? -1.0. Yes, no, maybe so on that one. All right, start taking a look at the graph of this. Okay, I take a look. I have a vertical phase shift of -1. I have an amplitude of 2. Okay, so my vertical phase shift is going to slide my axis down a little bit. Okay, and I have an amplitude of 2, so I need to make sure I stretch. So I'm going to be just a little top heavy here with my graph. I don't have to be much, but I can just be a little top heavy here. As we go through more and more of these, once again, you'll get more and more comfortable with respect to your getting your graph down. I just need to make sure I stretch down to at least -3 and up to 1. Now, if I take a look at the period here, the period is 720. Yeah. Multiplication. So you have -1 plus 2 cosine of 1/2 times 90. You have multiplication there. It's like a distributive property. Yes, no, maybe so. -1 plus 2 cosine of, type in -1 plus 2 cosine of 45. -1 plus 2 cosine of 45. Because that's 90 times 45, 90 times a half. Huh? 0.4. There you go. Is that better? Okay. You gotta speak up, folks. My calculator in my head sometimes don't work. Sorry. Can't be perfect all the time. Can't be like you, Braylon. Okay, now if we take a look at this, I have a horizontal phase shift of -90 at the period of 720. So I need to be able to stretch this out. I don't need to make big 90s. I need to make smaller 90s. Because I have the periods bigger, I have to make smaller 90s here. So I'm going to stretch this only I have 90, 90, 180, 270, 360, 450, 540, 630, 720. And once again, if the period is bigger, then you have to be able to make your 90s a little bit smaller. If the period is small, then you can make your 90s a little bit bigger. Okay, first thing we draw in is your prime axis. So at your vertical phase shift, you draw in your prime axis. So at -1, draw in your prime axis. Second thing we look at, horizontal phase shift in our trig function. Horizontal phase shift tells us our theta start value. So at -90, I'm going to start my theta value. My trig function will tell us on the prime axis are peaks and valleys, but it's a cosine curve. So do I start at peaks and valleys or prime axis? Cosine curve, peaks and valleys. So if I have to go to a peak, what else do I have to look at here? What else to look at if I have to go to a peak? What do you think? What tells us what our peak is? The amplitude. The amplitude will tell us what our peak is. So at -90, is my theta start. I have to go from a peak at -90. Well, my prime axis is at -1. I have an amplitude of 2. What is my y value going to be at the peak? If I'm at -1, I have an amplitude of 2. Right? 1, very good. Because I have to have this amplitude of 2 from your prime axis. Your amplitude comes from your prime axis to your peak or to your valley. So at -90, we're at 1. The third thing we take a look at is the period. If I start at -90, I'm at 1 at -90. 720 degrees out that way, I'll be at -1 again. What will be the degree measure? 630. Once again, you could just take the period and add it to the vertical or horizontal phase shift. So at 630, we'll be at our peak again, which is at a value of 1. Now we play our games of halves. Halfway between -90 and 630. 270. Where will we be at? Okay. Now not at 1. Now think about what a cosine curve is going to be. We start at a peak, we scream all the way down underneath and then back up again. Between any two peaks will be a valley. Okay, so what will be the valley here? At, you say, is 270 or yes? All right. Okay. At 270, what will be the valley? Nolan? Now, what's the valley from our prime axis? -1? No, that's our prime axis. Okay, that takes us back to the prime axis. -4. Okay, I have to go 2 up to get to my peaks. I have to go 2 down to get to my valleys. I'm at -1. What's 2 down from -1? -3. Okay? Between the peak and the valley and the peak, prime axis. No one, you take your books and go to the office, please. Okay, between negative 90 and 270, the halfway point. Okay, what I want you to do is I want you to finish this graph out for tomorrow. We'll pick up there tomorrow. Adios. Have a good day. Yep, that's it. We'll go back for the rest of the period.